In this recording, we're going to learn how to take a word problem, set it up as an equation, and then solve it. So we have here some steps, sort of a process to use, but let's revisit that after we've had a chance to do an example. It'll probably make a little more sense. So let's dive in and look at exercise 1. So we're looking for a number here that has particular traits. And so it says the sum of the number. So as you're reading through this, let's underline the important stuff. So we've got the sum of the number, and we need to be familiar with what that means. And 5 more than a number is 17. And the question is, well, what is that number? So we need a way to represent the unknown, the number. We're going to call that thing x, right? You could use a different letter, but let's keep it simple. Let's use x. Okay, so we're going to make a let statement. We're going to write something like this. Let x equals the number. And this part is really important that you define that variable clearly. Because after we solve for x, we're going to want to know, what would we just find out? We solved for the number. Okay, so the sum of a number. Okay, so sum means add, right? Maybe we just make a little note. And 5 more than a number. So 5 more than. Okay, that means the number plus 5, right? So we start with a number, which we called x, plus 5 more than the number. So another x plus 5. Okay, that's the 5 more than the number. Is, okay, so that's going to be our equal sign, is 17. So what you should be doing as I'm writing is you should be writing along with me. You should be making your paper look like the screen. Okay, and if you need to pause, you can pause. There's going to be a point where I ask you to figure it out on your own a little bit, and you can do that. At any point, you could rewind if you like. Okay, so now we just need to solve this equation. So really, those parentheses don't mean anything at this point because there's no coefficient. There's no number to be distributed. There's no negative sign. So let's just combine like terms. So we have 2x plus 5. And why don't you see if you can solve it from there? So pause the recording, solve for x, play the recording when you're ready. Okay, so hopefully you took time to work this out. Check your work now. Subtract 5 from both sides. Divide by 2. Those divide to 1. These added to 0. And so I've got x equals 6. And we should always write a sentence to answer our word problems. Okay, so our answer is a sentence, and it doesn't have to be a complicated sentence, but it basically should answer the question posed in the problem. What is the number? The number is 6. Let's go back and look up at our steps. Clearly define the quantities with a let statement. So you could have used x, or you could have used n. N is often used as a number. Okay. Common sense variables means if you're solving for like apples and bananas, number of apples might be A, number of bananas might be B, something like that. That's what we mean by common sense. Use your let statements then to write out expressions for quantities that you're interested in. Okay, so we talked about here, we might have x, and then 5 more than the number. We might say something like that, like x plus 5, okay, something like that. Carefully translate the information you're told into an equation. Okay, so we did that. Solve the equation. Mentally noting the justification, like, okay, I'm applying negative 5 to both sides. This is the subtraction property of equality, something like that. And then finally, as it says, this could be the most important but often neglected step. Check the reasonableness of our answer. So you don't have to show the check, but let's just check it in our head. The number is 6. Well, let's see if 6 works. If I take 6 plus 5 more than 6, which of course would be 11, 6 plus 11 is 17, so we feel good about that. Second one, the difference. Okay, so let's get into this one. The difference between two positive numbers, so I have two numbers, is 72. So I know difference, I'm going to just make a little note here. I've got subtraction. The larger number is 10 times the smaller. And this is tricky because we have the two numbers that we have to find the question is, which one should be the x? Well, the smaller number is what we're basing the larger number on. So if we call the smaller number x, we can call the larger number, which is 10 times it, 10x, right? And then we know we're going to find the difference, and it's going to come out to be 72. You getting all this? All right. So let's start out with difference. Well, excuse me, let's start out by our let statements. So we're going to say let x equal the smaller number. The larger number is 10x. Okay? Again, feel free to pause, feel free to rewind. And I want to do the difference between them. Well, the question is which order? Well, it comes out to be a positive difference, so I better take the bigger minus the smaller. So I'm going to do 10x minus 1x, and it says it's going to come out 72. Great. Go ahead and solve this. Play the recording when you're ready. Okay, so hopefully you paused, worked this out. Combine like terms, you have 9x. Divide both sides by 9. X equals 8. Then we have to write an answer in the form of a sentence. So the larger number is 10 times the smaller number. So that would be 80, right? And the smaller number we found was 8. So we'll say the numbers are 8 and 80. Let's do our check for reasonableness. The difference between our two numbers, is it 72? If I do 80 minus 8? Yep. And is the larger number 10 times the smaller? Sure is. Feeling good about it. Last one we're going to look at in this video. Okay? The sum of two numbers. Okay, so I want you at your own pace to make some notes on this. I want you to label this thing up, underline anything that's important. Play the recording when you're ready. Okay, so hopefully you did sum. Okay, we're talking about plus sign. Is 38. That's important. Okay, now we get to the relationship between these two numbers, because all we know is they add up to 38. And I can think of tons of numbers that add up to 38, right? So we got to know something more specific. One number is 2 more than 5 times the other. So we want to translate this into algebra. So 5 times, that has to come first, right? The multiplication. So I might do something like 5x plus 2. So 5 times, and then 2 more than that. So we got these two numbers. Let's create our let statements. Okay, x is going to be called the first number, and the second number is 5 times 2 more than 5 times, so 5x plus 2. Okay, finally, we've used all the information except for this first statement, the sum. So we've got x plus, I'm going to put parentheses around these numbers, the number that is an expression. I've got parentheses around it because sometimes it will matter. It will matter in a subtraction. So let's just be in the habit. Okay, so finally we just got to do the math. Parentheses don't make any difference here. So go ahead and do the math. Play the recording when you're ready. Okay, so if you pause, work this out. We can just add like terms because we don't have any coefficient here. So 6x plus 2. X equals 6. And therefore, the second number, which is 2 more than 5 times. I have to do 5 times 6, that's 30. 2 more than that, 32. So 5x, subbing in that. So that's going to come out to be 32. Let's just double check that it makes sense. Sum, meaning add. Yep, they add up to 38. One number is 2 more than 5 times the other. So if I take the smaller number, do 5 times it, I get 30. Add 2. Yep, that's 32. Checks out. Thanks for watching.